In this episode of the ICONSMAT podcast, we are joined today by Bogdan Majkic, also known as Danny, inventor from Melbourne, Victoria, born into a family of generational blacksmith masters. Started making things from first days. Born in Bosnia, Serbian origin, finished machining technical school, plumbing and central heating. Landed into Australia February 1990, where worked as self-employed painter and maintenance guy. Along that trade, Bogdan mastered many other trades and covered so much from or in building industry. Don worked in building and construction basically whole his life. Bogdan has a hobby and huge talent for inventing. Had 2 patents granted here in Australia. One was energy patent and called Super Hydropower Station, and the other one was for the construction industry, a new foundation patent called Shock Resistant Foundation for a building structure. Those were successful patents but lapsed now due to lack of interest in those technologies. Bogdan is now awaiting another patent for construction industry and invention of a new building block. New building block, which is called Tara building block, is set to revolutionizing building of homes and many other things. Tara building block is designed to replace wood and wooden structures, steel structures, and to preserve the environment at the same time. Completely new and different building block, which simplifies construction and efficiency. Bogdan applied for patents in past for many other various technologies. Due to the lack of funds, many were not successful, also but on records of a patent office. Bogdan still invents and seeks for sponsorship and financial help so his technology can see the light and also the reality. Bogdan Majkic, or Majkic, sorry for pronouncing it a bit wrong, is a man of many talents, and his popularity is growing on Facebook and all over the internet, where most of his work was published in the past 10 years. Bogdan believes that every problem has a right solution to it, and that he can solve any problem given to any kind of industry, technology and environment with right approach, that is, of course. His one of many quotes, around 700, is the best is yet to come, and his words are so promising for betterment of this world. Hello everyone, thank you so much for joining us today. We have the privilege to be with Danny, one of the brightest minds in the field of construction, with so many innovative patents registered here in Australia and also New Zealand. One of his recent patents had attracted so much attention, and that is why we are here today, to know more about this innovative approach towards building resilient foundation. Danny, would you please explain to us what exactly this patent is, and also about your experience in commercializing this patent as well, because I'm sure many of our graduate students can benefit from your past experience.
Well, sure, why not? That's why we're here. I attended builder's course. It's been, I think, 2011. And when we were learning about foundations, I realized to solve some issues that classic traditional foundations have. And I come up with the idea to introduce new raised foundation from the ground, if you like to look that way. Foundation that I come up with was similar to bridge structure, which I didn't think of that at the time, but now I'm confident that's very similar to bridge structure. So you can see it as a concrete foundation that is raised above from the soil above, and it can be restumped if you want, or re-level it if necessary. It's made from all precast elements, locked in by a top plate, which I will explain later. Locked in with a 100 mil top plate concrete, which locks it all in. It keeps it strong, bolted all together with rubber washes, so allows little movement, and is designed for shock resistance to absorb the shock in case of earthquake, in case of soil collapsing, to movement. It can be balanced, it can be leveled. It eliminates the moisture factor, it eliminates the cancer concrete, it gives the good ventilation all underneath and all around, similar to house on stumps, but this is in concrete. It's made from all kind of different shapes, precast elements, and everything rests on the footings foundation, which is first done when it's constructed. So it's in my opinion, it's quite interesting and very, very advanced foundation, which outbids every other foundation we have so far. If you're looking at the high-rise buildings, you can see that every building's got a kind of cellar or a couple of stories below ground. This is same kind of thing because the domestic house, which this foundation is primarily designed for, it's raised above ground, and it simulates like two stories under the high-rise building, where you can have access for storage, access to maintenance, do whatever you really like with it. So I can show you just pictures of whoever's looking at that to have a rough idea what's going on. This is it. Precast elements.
Do you want to share your screen? Because you can now if you want.
Sorry?
You can share your screen now if you want.
I am I? Ah, yes, sorry. Shit, yes. Okay, this is the image of basically what foundation is all about, what it looks like. So we got precast elements lined up, all set on the footings below. First we do footings, then we place rubber mats. Entire foundation rests on rubber mats, and which are placed on footings. And then it's all braced to the eye bolts, which are concreted in the footings prior. When all lined up, it creates channels all across and along, which are reinforced with trio and steel. And then on top of that, we lay 100 mil or 80 mil, 100 mil recommended, top concrete plate, which locks all in and hold it strong, durable. And in between below, we use bolts with rubber washers, which we connect, all tighten up, but allow slight movement in case of shocks or earthquakes or something, so it doesn't crack.
What type of mat you mentioned? It's a plate. It's like is it type of a plastic or rubber mat?
It's a hard rubber, which can be designed just like on bridges, for example, to withhold enough weight and be flexible enough to absorb the movement. But when you sit the structure on rubber, it can move, but that's not enough for this foundation. So I allowed extra tolerance here, if you see around the eye bolt and there all around. So that tolerance is to make it move even further, like say 150 mil around the eye bolt. Reason being is to sometimes when you have a sudden shocks sideways, you need to allow room to move, and that's why. If it's only sitting on one place and tightened to one bolt, it wouldn't work.
Causes cracks. That's the main reason that buildings fail after some shocks or earthquake, landslides.
Yes, they do. The first instant shock, that's what damages the most. And this is, I'm pretty sure, I cleverly thought of this. So there's two options here. We can run on top of rubber mat. We can run stainless steel plate or something that's it can be even hard wearing plastic or something that's weather proof, so it doesn't get rusty. So we actually make that movement smoother instead of rubber. On the rubber is stiff and it will only move as much as the rubber tolerates, right?
How did you come with this idea? Like, what was the initial, like you mentioned that you're a super problem solver.
Yes, I am. I'm confident.
That's great. Like, what was the initial, let's say, problem that this solution is going to tackle?
Well, I was all my life basically involved in construction from my first childhood years. And we were all, I'm originally from Bosnia and Yugoslavia, where we used to build houses from building blocks and concretes, and I used to mix a lot of concrete by my hands and have blisters all around. So I know concrete. I grew up with it, right? I know foundations. I know buildings. So when I attended builders course, as I said, we were learning about foundations, and then the teacher was saying how concrete can get a cancer from mold, from moisture below, and the moisture itself is a very negative factor for any construction. And you see it, I got it even around my house. You can see dampness and moisture affecting lower ends of any dwelling. So then we learn about structural concretes, about footings, about land and soil movement, about different types of soil. And as he was saying, which is me, I'm thinking how to find a better way, straight away. And I clicked to it. And I thought, okay, if we rise that above ground, if we use precast elements, line them up, rise it above ground, so we eliminate the moisture instantly. So this foundation is not in contact even with the footings because it sits on rubber mats. So that's instantly eliminating moisture from the soil, contact with the soil, which instantly gives ventilation and eliminates moisture factor, which is number one thing important, right, to me.
It does two things actually. One is that it prevents the moisture to get into concrete and makes it, like, let's say, more healthier from getting the
allows the foundation to breathe. Allows it to breathe, yeah. And but then I thought further about shock and earthquakes and shock resistance. Then I thought, okay, it would be good to sit this on something flexible, and then brace it around. These are bracings here. These are elastic steel cables. So in my specification, that's all explained clearly, what is what and what does it do. So I come up kind of complete new way of building the house, not just foundation, because what's happening next is brick wall. We're not resting on the footings, we're resting it on the exposed, what's it called, like
the mat.
section, exposed section, which is part of the precast element itself. So we rest entire brick wall or blocks or any cladding above footing. It's not sitting on footing. So if entire foundation is gonna move, brick's gonna move, and that's also making it walls flexible and minimize the impact of possible damage or cracking or something like that, which we can reblock the walls as well, which is common problem for quite a. I used to paint homes. I used to have my own business, maintenance, renovations, and I seen it everywhere, cracks everywhere, problems with the buildings, you name it, everyone's got it. And but this is suitable for any type of soil, very suitable for, especially for earthquakes, and that's why me and which I will show you later, I had two two guys with me on this application, but I'm an inventor of it. But they were just applicants with me on the Python. They were my teachers on the Builders course. So I thought would be great to use teachers here to help me make this happen, because it's a huge task to from idea to patenting, and then commercialization, and then bringing it to the market, getting it approved by building board, by the building code. You need building code as well for that, and then to be finally used by people.
At what stage is this patent currently?
Well, that Python I lapsed deliberately because I'm on disability pension and I can't afford buying requirements and renewals. So I come to the stage of where you've got to pay $1,000 a year, which is quite a lot for me. I'm always struggling financially for the last 20 years, you can say.
We had like so many similar situations as well. I myself, I was doing a PhD, came up with a new type of chemical admixture, and keeping the IP, it's a pretty costly process. But I guess the most effective approach to protect an idea is to keep some part of it secret, like what McDonald's done, like what Coca-Cola done. You know, have you heard of the secret sauce of McDonald's? For a few years, they wouldn't relieve the mixture that they've been using in their sauce. So similar thing can happen to any type of innovative approaches. Let's say if there is really complicated part in this patent, you can keep it secret and then apply it once it's being implemented on a project. Again, like what we're doing at the Institute is to have brightest minds and brightest idea like yours to spread and reach more people, and they can use it on their benefit as well. So yeah,
I can comment on that, what you said. This was kept secret during the patenting process. When we got a patent, then I started marketing, publishing, which is mainly Facebook and LinkedIn. I tried to attract some interest in it, which is really hard. Marketing is most important part, and this is actually one way of marketing what we're doing now. But too late for me because I don't have rights on this patent anymore. It's lapsed. So the reason why I'm doing all this with you, Farid, is to inform people out there about better way, about more advanced foundation, about more advanced buildings in general, and which solves quite a few issues and problems, and simplifies construction in general. So this foundation can be done once you do one day footing, next day you can finish it. So 2 days job done. No much soil work, no much sand. Sand work is, for example, eliminated. There's no, when you're leveling sand on top that's eliminated. You don't need plastic or polyurethane film on it. You don't need basically anything. Just what you can do is seal precast elements when they might in factory. So basically all you do is just line them up, brace them, see them on the rubber, top plate, foundation is complete, and you can instantly start building on it. Nothing to worry about curing of concrete, which normally should take 28 days for every concrete foundation, but nowadays builders they pour the concrete foundation today. In 2 days they're putting prime and adding white to it, which also causes cracks and movement of unsettled, uncured concrete itself. So
I've seen a bit of examination as well you've sent before. So is this undergone an examination, like a structural testing?
Well, nobody tested it yet. It wasn't mine. I can't afford financially to build. I could do small little, but that's a little prototype, but that's not good enough. So I would love to see this done in real version. Just by looking at it, I know it's going to work 100%.
Oh, like
Advantages.
we need a structure analysis, just like you mentioned, for the building codes. That's a part of, I guess, having a IP being commercialized, so that we make sure 100% based on all the existing examination and tests. Because you've sent a document about, I think it was in 2013. It says we have filed a request for normal examination and a copy is enclosed. I guess, was it by Davis Collision?
Now they're my lawyers, they're my patent attorneys. I use them because we lodged the application in New Zealand as well. Reason being because New Zealand is well known for earthquakes. So this is perfect solution for domestic construction in New Zealand or basically all around the world. It can be utilized. But what I wanted to add is I get nothing out of doing this with you today. I don't have rights on this. The only one reason I'm doing it is from my free will, from my good heart, to inform people and students and young ones, industry itself, that this is potentially solution for future developments, and that can benefit basically everybody, the entire world.
Nobody has the rights more than you, definitely.
No, but I don't have a right legally, so I can't sell it to you information or to anybody else. It's yours. Whatever I'm trying to explain, and I was a bit nervous at first. Now I'm getting better. Whatever I'm explaining, it's a gift to all of you guys. If you see potential in it, I would love to even be still part of making this, developing this, testing this, because I know that all little things that you have to think of it regarding this foundation. So I could help, obviously, out of my free will, right? So that's basically rough idea about foundation. But advantage is huge, in my opinion, compared to conventional foundation, because right now my foundation is sitting on the ground. I see the cracks, I see this. That won't happen here. Another important thing is once we erect foundation and put a top light, it basically gets reinforced all on every square inch of it. So internal walls, regardless of channels in footing, don't have to sit on channels in footing. That's eliminated instantly. You can put internal walls anywhere you like, in any position, any section of the foundation, which is designed to, because of top light 100 mil, plus solid and strong durable precast elements. That's strong enough to hold even 5-story building. And that's what I have in mind, to develop them strong, so it can hold really a lot of
Can be
light.
customized too. Like if you play around with the thickness, with the width of the.
You can do it's subject to any size, yes.
Yeah.
Now, one more important thing. What is it? Besides the walls, I'm just losing it. What I wanted to say regarding precast elements, they can be any size, they can be any thickness, but I lost it.
That's all right. Yeah, really interesting. But the structure, and just to get to that point where the building codes come into effect, and so
that's a hard one. That's a hard one.
You gotta build some kind of trust between the builders. Like if anyone watch this and they go like, okay, it's a really good idea, and I need to know whether it's 100% works like a builder. How
well, I already showed to a few builders, they loved it, idea of it, but it's hard to understand. So not everyone, basically nobody understands that yet completely. This is first time basically I'm talking about via video, and in general I never spoke to anybody about this foundation. I did publish images, but it's different when you talk in person But don't lose the subject like I just did before.
Mm. So
uh,
we're offering online courses as well, Danny. So if you're looking at making this more popular and let more people know this, the Institute offers platforms for bright minds like you to create online courses in a really structured manner, so you can get quizzes, videos, all sort of things for your students, and ask. We do the marketing for you basically as well, to get the students and the next generation knows how to build a foundation like this.
well, I think that's best if you guys do that and push for that, because I'm limited. I can only do so much. And I think I've done enough. I designed it, I Python that, which is labs, doesn't matter, but still it's on records and it will stay on records in Python Office. If someone wants to dig in and search Python Office, they will find this new foundation. And it's up to organizations, schooling, education, or individuals, or construction boards, or building boards, if they're going to approve code and if it's going to be tested by someone and developed. But I can only do so. I'm not interested much in doing courses and explaining and teaching, but I'm quite happy to help as much as I can to explain. And once we do, for example, this will give idea roughly what's all about. I'm pretty sure some people will click just by looking at the drawing, but young ones, students, well, they're pretty intelligent as well. So it's not a complicated thing. It's quite a straightforward foundation. We can do, for example, completely long, all the way from one end to the other, or across precast elements. It doesn't have to be sectioned as I did. But the reason for those sections is to reinforce more sections in more places, to reinforce foundation itself with the channels. Because when you line them up, you see that becomes like a channel. And when you pour concrete in that, it's reinforced steel, which is probably 200 mil thick. And that's like a beams in structural, in high-rise buildings, or beams, or in European housing, they do those beams 200 by 200 or 300, and that holds quite a lot of weight, and that's perfect for internal walls design. You can build them. There's no wood in new. Actually, I got to tell you this. I have a application in Python Office for new Tara block, building block. So I'm trying to eliminate wood completely, because the shortage of wood becoming worldwide now, and to save environment as well. And that's another thing you got to think
Really
of.
important.
Environment always. So these precast elements, which I will show you different picture and in color, which is this. Okay, this one is red. There's a reason for that. So I was thinking, what's the most suitable material to use to make those precast elements? So I come up with the idea of volcanic rock, which is red rock, the scoria that we use anywhere around the house, the cheap one, right? Apparently, when I did that course, I was told that's not used much in construction and in concrete, because it's got too many air bubbles, air holes, and it cannot hold the strong structure. So I thought if we crush that to 7 mil, 6 mil, or 10 mil to make it, they're normally around 20 mil, 25 mil size pebbles. So if we crush them to smaller units, then the connection, the structure will become stronger, because it grabs it quite stronger, then cement will hold it stronger. And that's why I pointed
It's
this.
still concrete.
It's still concrete, but it's made from scoria rock, volcanic rock. Volcanic rock is ideal material because it's been exposed to enormous heat in volcano itself. So when it's erupted, it's thrown everywhere, right? It won't heat and cold. It will not dilate much. It won't expand or shrink or cause a lot any kind of expansion and any problems in that field. So I reckon that this is suitable material, quite good, and we got plenty of it. We don't know what to do with it basically, and it's cheaper than any other sand or concrete or crushed rock or anything out there. And we got billions and billions and billions of tons of it worldwide. So basically anybody can build anywhere. And it can be even the black volcanic rock, but this is the idea. I come across on Facebook one post where somewhere in Greece, they built it on high rock foundations, entire place. I forgot the name of it. Everything was made actually from scoria rock, from volcanic rock, and it holds for thousands of years already. So it's definitely, the Romans probably used it in their structure. So it's definitely proven material, which I didn't know originally, but just recently, a few weeks ago, I come across that post, and I was actually wrapped because it kind of confirmed that I was right on that. But obviously, it's subject to research and testings of materials and everything else. So,
shake tables in universities all across Australia. Guess we have a really good structural laboratory in the Western Sydney University Kingswood campus. Not sure if they have shake table, but what I've seen was that they have a lot of large gauges that test the structural resistance of multiple elements, whether it's a beam, whether it's a foundation, whether it's a wall, column, all sort of things. But yeah, so the next step for a novel idea like this is to push this into a structural laboratory and get some results out of it. Because once we get architectural drawings, then the civil engineer will come and modify or customize your patent based on the architectural demands. Oh, so it's a new bracing here.
well, here it shows the bracing and a little gap around it to allow more movement. It shows the precast element with the lip, overlapping lip. That's where we rest the wall on this section. Then it shows the channels when it's precasted. Those channels can be even deeper, or it's basically optional design. You don't even have to have them. You can have a flat straight and finish without a top concrete plate. You can have them straight and just hit the foundation, but then you have to lock them in nicely so the joints are nicely, smoothly finished, and make them stronger, because that 100 plate on top of concrete, I like it because it locks all in, and there's no way that foundation can move sideways or crack or expand.
Makes sense.
It can only go down, but even if it sinks, say footing sinks here or there, a footings can sink. We can, there's a new ways even to rise up footings, digging the ground and hitting more concrete and forms and stuff. But besides that, I wouldn't do that. Footing can sink still, even 200, you say, milli or even more. We can reblock this. We can support it underneath. We can level it. If it sinks, if it sags a little bit here and there, this is a perfect way to reblock, if you like.
Right. So because current conventional foundations, they are not in segments, they are poured all in one. And like you say, if one side sinks, then the whole building is being affected. But now with these segments, if one side sinks, the other side will still stand as it was.
That's right. And that's why we got across here, across there, when we join, and they join with the bolts, which I got images of it somewhere. Okay, not here. They join with the rubber washers and bolts, so to allow additional movement and absorbs even shock between the blocks, between the precast elements, which is down in lower end, you can say, because concrete top plate holds it in upper end. And then we have eye bolts, which these ones. Eye bolts are concreted into foundation. So to erect this foundation, we will do first plan. We get off the plan, I do footing. Plan goes to factory. Factory goes by measurements of footings. Everything is already pre-done. Eyebolts are concreted in footing. Factory does precast elements, brings them on the side, just lines them up, bolt them together, cables, brace them all around, and allow, of course, room here for the brick wall.
These are some special bracings. Are they available in the market, or does it need a special manufacturer?
Well, you can have kind of a little bit elastic cables to it. Has to be stretchable, right? So you allow, say, 100, 200 mil tolerance max, but that's engineering department with steel fibers and structural materials. You can have a springs, you can have elastic cables, as I said, and as long as it stops it not to move further than what's designed, right? And so it gives you that flexibility about 100, 150 mil in all directions. Right? So this way, if your foundation is gonna shake and move, entire foundation will shake, and everything will still sit on rubber footings, on rubber pads, and it can be even pushed back to original position. The entire house can be pushed to original central position if necessary. Say after major earthquake, you can even use jacks and move it to original position, so to prepare for next time if necessary. I'm just saying.
Right.
So what I did next is I invented the building block, and I applied for patent on that. I got also partner on that because to share costs of patenting, I can't afford all this, but I love doing this. All my life I spend in this. I'm thinking.
They're pretty expensive ideas. Like nobody is able to come up with such ideas. So I mean, it's absolutely.
They can, but to fund all this and to build all that, it costs fortune. People invest millions in research, R&D, research and development. So what are you expecting from disability pensioner to fund all this? Impossible. So I would love to see this adopted by someone and tested and made. So to see, I know for sure, I'm confident that this is problem solver for every foundation, every future development site or house, mainly for the houses, but you can easily develop to suit 2 stories, 3 stories, which is good enough. Much better than a waffle slab, better than conventional slab, better than pillars in the ground, right? This solves everything. So channels are so easy to construct, the footings. And regardless of what kind of soil, really, if you got rocky soil, clay, whichever, it doesn't affect because it's raised above ground. And that's the #1 important thing. So, but next thing I thought is to eliminate the wood, which I done, and that's where my Tara building block comes in. That's coming soon. We should be granted patent within a month, hopefully. That will eliminate structural wood completely. It could eliminate plaster. It could eliminate ducts in the heating. It could eliminate what else? Quite a few different things.
Even great to know about that, but since it's going to be kept secret, I guess
it's still secret, but not for long. Hopefully, I can show abstract about that. We can just put it here. That's it. So basically what it is all about, eliminates the wood, saves the environment, gives a completely different block look, structurally as well, and it solves quite a few different issues. So once, basically what it's saying, it's time to start thinking of building a different kind of housing in Australia and around, because there's shortage of wood and cost of it. So once we introduce this future block, hopefully coming soon to the market, this will eliminate, or again, quite a lot of different problems and make things much simpler and easier. So that's all I can say about that at this stage. But it's also designed to eliminate moisture and mold and stuff like that. So that's something I would love to share with you this time, but I can't next time.
Hopefully next time we get
but for now, foundation, I have quite a lot of different technologies, about 60 of them. I could every day I can.
So how can our audience be in contact with you, Danny?
Well, you got my email address. That's the best way.
Okay, we're gonna put it somewhere in this video.
You can add it up if you like. So that's another thing I like to mention. This is a precast. Future of the dwellings and development is in precast elements, right? I believe that strongly.
That's
so
right.
Future homes, we will just do the foundation or some footings or some kind of foundation. It doesn't have to be this one, and just erect the house on it, all done in it. That's going to be future. This is one of my designs to help homeless people around the world. This one bedroom apartment, which is holding everything you need, and it gives quite a lot of room according to my design. Simple. We can erect in any park, anywhere along the beach, anywhere, caravan parks, you name it, and help homeless people around the world. That's my wish from my heart, to help those people, because any one of us can be in that position and kicked out from wife or husband, so who knows what. But we have to take care of homeless people, definitely. So I thought of them and I designed a little structure, which is precast house with self-sufficient, by the way. My wind turbines, my design, my solar system design, not conventional. I got everything for this entire buildings. Next thing I'm planning to do is precast structural ceilings, which are already out there in some high-rise buildings development, but I see them and I'm not quite happy with it. I got something better in mind. So hopefully this comes. So we have foundation, we got walls, block, then we have ceilings and roof. Roof is optional. I have some ideas about the roof as well. So my goal is to complete entire house with my own unique suggestions and ideas and designs of it. And that's what I'm hoping I will achieve.
Thank you so much.
You're welcome
for joining us. I've learned a lot about your experience and all these ideas. Definitely, I'm sure
it's fun.
More people are going to come back to you and ask questions from your innovative ideas. And best thing that we can do is to push these ideas into structural laboratories. So if anyone is working in a structural laboratory, seeking to do a PhD, this idea is going to be the future for you guys. Just definitely go ahead with it, do some laboratory tests, and you'll be good to go with your PhD candidature. Thank you so much again, Danny.
No worries, Farid. This is published on Facebook, on internet. So if you Google just this Bogdan's Additive Advanced Technology Foundation, you will, that's a way to contact me if someone wants to contact me, plus email address. Thank you for having me, Farid, and I hope I explained quite a lot.
Awesome.
Something good.
We'll be in touch later.
Thank you so much.
Have a nice day.
Same to you.
Goodbye.